think we can wait for people to join. Okay, I think people are joining in. That's great. Hey, folks, welcome. Just give a quick few seconds for everyone to join in. And Richard is already with us, finding the sweet spot and waiting with us to start the session. All right, let's get started. Hello, everyone. Good morning, good evening, wherever you're joining from. Welcome to TestMu 2022. This is the first and a very special edition for all of us at LambdaTest, and it's also going to be a special edition for you. And we really hope that it's going to be a special edition for you. And we have a lot of sessions coming up right for you. And we want to kickstart the TestMu with none other than Richard Bradshaw, CEO of Ministry of Testing, with a special keynote. It's called a TRIM, giving a valuable inputs, insights into test automation. A bit about Richard Bradshaw before we dive into the session. I've been knowing Richard Bradshaw for a very long time. I think we met Richard in 𝒄𝒐𝒏𝒇𝒆𝒏𝒄𝒆 Conference London, 2016, if I'm not wrong, and he's been a fantastic educator, fantastic evangelist for testing. Has been in the testing world for more than a decade and a half or so, if my memory serves right. And there's lots of YouTube tutorials these days. But if I have to look back a couple of years, I think it's Richard who started that era of having a clean slate whiteboard and teach about testing. I still remember those days, and Richard, you should have continued that. But nevertheless, I think the knowledge that you have been sharing from all those years has been fantastic, and the things that you have been doing through our Ministry of Testing is pretty good. And we can't wait to hear what's all in store for the keynote. And welcome to TestMu.
Thank you very much. Hello, how you doing, everyone? Yeah, I should keep doing them. I've got a new whiteboard, so I will do some at some point when I can stand up comfortably again. So, yeah, Manuj making jokes. I've had an operation recently, so I can't move much. So that's why I found a comfortable spot to sit down. But yeah, I really appreciate all those kind words. Really kind. Thank you.
Appreciate all your efforts for recording the session for us, Richard. So folks, we're going to have a recorded version of Richard's talk, and he's going to be all here looking at your chat. So keep your questions coming in, and we will dive into the video.
Enjoy, everyone. Look forward to the Q&A. Welcome to my talk here at TestMu. I hope you're having a fantastic day. And yeah, might as well just get straight into it. So the talk is titled, It's Time for a Trim. First things first, it is not about me. Yeah, yes, this needs a trim. This is a bit raggedy, and so's the hair. But I've recently had a very minor operation, and I can't really leave the house. So it's going to have to stay a bit like this. You're kind of just going to have to deal with it. But it's not that bad, is it? No, what I'm referring to here is your automated tests, or your automated checks, whichever you prefer. This talk is framed around the notion that we tend to just automate and automate and automate, and we end up with these large packs of automated tests, and not these, like, packs, probably not the right word, but large suites, large code bases full of these automated tests. And very rarely do we find the time to just stop and actually ask the question, are these tests any good? Do we need to keep them? What risk is that one mitigating? Why have I got thousands and thousands now? Do I need them all? So it's about trimming your automated tests. That's what this talk is going to be focused on. I'm going to share with you a fantastic model that I've created along with my colleague Mark Winteringham. And then I'm also going to share a few stories just about how I ended up creating the trims. The model called trims. All right, so yeah, let's dive straight into it. So yeah, I'm going to start by getting you to do some work. It's one of the fantastic things about being at an online conference. So I'm going to get you to in the chat now. I'm going to be in the chat as well. Power of time travel. But I'm going to be in the chat as well. And I want to know, when was the last time you deleted an automated check? So don't overthink it. If it was this morning, boom, right this morning. If it was last week. If you've never done it, That's cool, that's fine. So yeah, when was the last time you deleted an automated check? All right, so I'll tell you about a few stories of my own that thou shalt not delete. So I've been on many automation projects. A large part of my consulting career was really focused on helping teams get started with automation or trying to improve existing automation that was already there. So I often found myself on teams with hundreds, thousands of automated tests, and they were like treated like precious little diamonds, like really high value. It's like, well, if it's green, why would I delete it? And I remember having lots of these conversations with the team where, tests were passing. They were giving us, overall, we believed they were giving us great feedback. It was green. Things were, relatively reliable. But then I started digging a little bit deeper, and I started to spot a few tests that it's kind of question yourself, like, why is this here? Like, does anyone care about that feature? Let's just delete it. And there was immediate pushback from the team and my manager. It's like, what do you mean? It's like, just delete it. Yeah, but why? It's not doing any harm. It's, it's there, it's running, it's passing. It's not doing any harm. Why would you want to delete it? And I was like, well, it's not really adding any value. So yes, it's green and it's exercising a part of the system, but that part of the system is underutilized. That part of the system, that actual area is covered in these other types of tests that we have. This additional test is kind of just a waste. And I got so much pushback. And at the time, I wasn't really in a position or had the confidence or knowledge to push even harder than that, so you kind of just accepted it. And then what started to happen all the time was our builds just increased and increased and increased. Every time we build a new feature, we're adding a whole new set of tests into there, and you just start to see it slowly creep up over time. A minute here, a few minutes that week, and a few minutes this week. And lo and behold, soon your build's taking 40 minutes, an hour, 2 hours. And we all know, right, that we want 10-minute builds, right? 10, 15-minute builds. I would love a 15-minute build right now. On a quick side note, I spend most of my time nowadays building the front end of the Ministry of Testing website, and our build has creeped up. Our build, I think it's 18 minutes at the moment, so I've got to do some work to get that down. I've got to take my own advice from this talk and get that build time down. But yeah, basically, I got so much pushback that I wasn't able to delete any tests. And it was a similar story when I went to another company. Same story, same pushback. Well, we've put all this money into these tests, all this effort and time. They're green, they're running. Why would we delete them? And I'm not going to share now why we won't delete them. I just wanted to make you feel aware, maybe help you try and relate to some scenarios or contexts that you may be in, where you've had similar messaging, or maybe you thought similarly yourself. But I now no longer believe this is the case. We need to be regularly we need to be regularly reviewing our automated tests, seeing if they're adding value, see if they're actually helping our overall mission towards testing and quality, or are they actually just kind of taking up time. And I've been giving that a lot of thought. I'm going to share a few thoughts now, and I'm going to share the TRIMS model with you to hopefully give you a model to take back to your companies and maybe trim some of your automated checks. So in the chat again, let's utilize this online platform, let's make it a bit interactive. In the chat, share some reasons for why you've deleted an automated test. Think of the times that, you've been able to delete them. What was it? Was it the was it the risk wasn't there anymore? Was it more that, it's broken, so you just delete it? Or was it one of those tests that you just can never fix? You keep thinking you fixed it, you keep giving it another go, another try, still broken, deleted, gone. I'm going to share a few reasons for myself. The risk it was mitigating is no longer valid. This is a really interesting one, and now I've mentioned the R word, risk, right? We don't talk about risk enough. It is so depressing that we don't hear the risk as often as we should be, right? That's a huge part of what testing is meant to be around, right? There's a risk. Does that work? What if it didn't work? What if that didn't work? What if that fell over, right? These are all framings around risk. What if that changed the way it communicated? And what if that API was down? What would happen over here, right? We've always got these risks going on, but we very rarely explicitly talk about them anymore, and I think that's a shame. Especially when it comes to automated checks, because the reason why we have the check in the first place, or an automated test, is because we believe it's mitigating a risk, and we believe that that risk is important to us. We believe that we want that risk mitigated. We can't have that risk out there in the wild. So therefore, we've written this automated check, and we're hoping that it's going to mitigate it for us. But what if that risk is no longer valid? And this poses a really interesting question. Can you go and look at your automated checks that you have right now? And is the risk obvious to you? Is it clear, the intent of that automated check? in a lot of teams and a lot of code that I see, and even some of the tests I write, a lot of them, to be fair, it's not very obvious all the time. We're not very good sometimes at naming our automated checks to make it clear what our intent is, what risk we were intending to mitigate. And that makes it hard when it comes to deleting. So let's say there was a risk. Let's say it was the launch of a system and we wanted to make sure that, some sort of helpful message was appearing, right? At the time of the launch of that feature, that is a valid risk. But now we're 6 months down the line. And yes, people are still seeing that prompt, but does it matter anymore? Is that test worth adding 20, 15, 30 seconds, whatever it takes, onto our build? We have to ask ourselves, is that risk still valid? And secondly, can we decipher what the risk was in the first place? A test might have been moved to another layer or scene. That's a fantastic reason for deleting a test. If your testability or your skill set, skill set is part of testability, but if the skills in your team have improved, you've maybe moved something away from being maybe a large monolith to like many APIs or microservices in there. Now you've got other layers and other seams that you can get into. So when I talk about layers, it's usually because we think of systems as hierarchical. The UI is at the top, APIs, code, like unit level kind of code, service code, databases, third parties, right? That's why when we talk about layers. I personally prefer to talk about seams. And the reason I like the idea of seams is like they're connected. You can have layers stacked on top of each other that aren't connected really. They're touching, as in they're stacked, but they're not really interwoven. Whereas you think of something like a seam on a t-shirt, for example, right? These have been stitched together. There's a contract there. There's something between them that's holding them together. But yeah, maybe you've been able to move a test perhaps from the UI, and you've been able to implement it at an API. So therefore, yeah, delete that UI test, especially if the risk is different. And we'll talk about that a little later on. Unreliable and flaky, right? Flaky, flaky, flaky. Yeah, we all love flaky automation. Of course we don't. But if a test is unreliable and flaky, and it's actually causing you to waste a lot of time debugging it, investigating it, we've all been there. We have a few administrator testing, right? If the build fails, you're like, what? This should never have failed. You look onto it, you see it's that test. You're going to rerun the build, and it's going to go green, and you're going to be like, and then you're going to try and fix it. You think you fixed it. A few days later, no, flaky again, right? You have to sometimes question and say, is this actually helping me? Is this giving me confidence in my automated tests? Is it giving me knowledge and information that matters? Or is it just causing pain and friction and slowing us down as a team? If that's the case, maybe delete it. If it comes back, it comes back. That's another thing don't feel scared of deleting tests. Sometimes, yeah, a risk might pop up at another time or an issue might pop up, and then you can revisit it. But you might have had so much benefit from deleting it during that time that it was worth it. It's worth it. So the features have low usage. This is another one that's often commonly overlooked, right? A large part of the work that we do now as teams is, are things being used? Are our features being used? Are people enjoying using our features? Was that feature worth building? We have a lot of metrics around that these days. It's something we're focusing a lot on my team right now. But if they're not being used, or being used by a select few, do you need 25, 50 automated tests covering every single permutation of that feature? Or do you just need the happy path and maybe a few other scenarios? Perhaps you don't need all of them anymore. Yes, they're green, they're passing, but at what cost? And we'll talk a bit more about cost, but obviously not just execution, but also they are going to fail at some point. They're going to need maintaining. You're going to update libraries. It's the cost that might come in the future as well. So yes, we don't want to not have any coverage on the feature at all, but perhaps we don't need as comprehensive coverage as when we originally built it. So they might be reasons to delete an automated check as well. The risk itself has been mitigated by another test. If you're on a larger team, there's people automating all over the place. Hopefully your developers are doing some automation as well. And then you might actually find a point where there's actually just tests that are doing the same thing. One might be on the UI, but really it's actually testing through the UI. Or perhaps you might have one on the API, but it's actually testing through the API and actually a unit level test. And maybe someone's gone back and added in a few unit tests that now mean that these other tests are kind of pointless. They're not covering anything. And there's a great mnemonic by Mark Winteringham called Tutu and Tata. Am I testing the UI, or am I testing through the UI? And what he means by that is, Is the risk that I'm actually trying to get to, is it actually a UI risk, or am I just using the UI to get the system to trigger something further down the stack? If that's the case, you want to be testing further down the stack. And then we have another one, which is tatter. Are you testing the API, or are you testing through the API? Again, there's reason you might, it's not saying don't do that, I'm just saying make sure you're aware that you actually are doing that. And then finally, is the test too expensive? A lot of the times, if you're working on very complex systems, there might be a lot of setup in order to be able to execute a certain test. Maybe there's a lot of data to create. Maybe there's a lot of dependencies to mock. Maybe there's a lot of services to spin up. Ask yourselves, are we getting value from that check? Because some of those checks can get quite lengthy. So we need to make sure that we're actually getting value from them and they're benefiting our testing and not actually hindering us. So, a few things covered there, lots of little side stories and little tips and tricks, but the thing that I actually, the way that I've now gone through this in the future, or not in the future, in the past, but now I'm sharing it with you, so hopefully you use it in the future, I created a mnemonic called TRIMS. And the idea behind TRIMS, as I said at the start, is that it's a mnemonic to help you evaluate existing automated checks, but it's also a model that can be used to design new ones going forward. So we're going to go through TRIMS. I'll tell you what they are right now. So it's targeted, reliable, informative, maintainable, and speedy. We wanted fast, so we put TRIMS, but it doesn't sound as good. So we went with speedy. But yeah, I'm going to go through these 5 aspects of this mnemonic now, this heuristic. And again, this is not like a guaranteed thing that's going to work, right? This is a model. This is a heuristic. And it might be useful in your domain. It might not be. I found it incredibly useful in the checks that I'm currently writing, and I found it a very good mechanism for teaching other people about how to evaluate existing automated checks, as well as designing new ones. So we'll start with T, targeted. Targeted to a specific risk and automated on the lowest layer the testability allows. So we've already mentioned layers and seams, right? We just think of the system down. What I'm actually referring to here when we let's go back to the top. Let's start at the top. Specific risk. We mentioned the R word again. It's not deliberate, I promise. But yeah, the R word, risk. It's really important, right? So we want an automated check. We want them to be small. People sometimes call it holistic or atomic, but the main thing is we want them to be small. And the way to keep them small is to target just one risk as best as you can. Just one tiny risk. Because it's better to have maybe 10 small checks, all on slightly different risks, than having one big check that's going to check all 10 risks. So first things first, what is our risk? Once we've identified the risk, we can then break that risk down to actually try and work out what layer I meant on. I'm going to show you a model to do that in just a second. Then we talk about the lowest layer. And the reason that I'm talking about the lowest layer is actually really, lowest layer probably needs updating. I actually think it's more about the less moving parts. The less parts of the system that we can trigger, the less steps, the less actions, the less behaviors, the smaller our check will be, the faster it will execute, the more targeted our risk is, and also when they do break, we're more likely to know what is broken, right? Because we've all had UI tests that fail, and it's like, oh, I wonder what it is. And you end up digging down 5 layers to find out actually it's the database that's broken. That takes a lot of time. If we were testing directly at the database or directly at the unit level, we would have got that feedback a lot quicker. And then finally at the end it talks about the lowest layer that the testability allows. Testability is a fantastic topic. There's lots of material out there. There's talks by myself on YouTube that you can watch. And there's a fantastic book out there on testability by Ash Winter and Rob Meany. They talk about the 10 Ps. But basically testability is your ability to test. It's as simple as that. But there's a lot of factors that impact your ability to test. So you may know that the lowest layer to test an API, to test a risk is on the API, but you don't have skills in your team at the moment to test on the API. You don't have time or budget to go and get those skills. So therefore your testability is not going to allow you to automate on the API. Therefore you might automate a layer up. So that's what we mean by testability. That's just one example. There's thousands we could do and talk about testability. It's a fantastic topic if you've never looked into it. But yeah, if you've never thought about testability, take a moment, take 5-10 minutes, sit down, grab a pen, grab a piece of paper, write down all the things that make it easier for you to test and all the things that are making it hard for you to test. And that's testability. So this is a model that me and Mark Winteringham refer to as a visual task analysis. So it's a terrible name, but basically it's to help us work out what risk are we trying to mitigate and on what layer of our system does that risk show its face. So on this example here, we're discussing a successful login throw, right? A very common example that you see in a lot of systems. Nearly all systems these days have some sort of authentication on them. So down the left, we've got the layers that we've identified. It's not extensive. It's just the ones that we've identified. So UI, JavaScript, API, database service code. And what we're trying to do is test that the user can log in. That's the test. That's the risk. Can the user log in? What if they can't? But when you actually think about all the things that happen when you log into a system, and in this example, it's just a test system, but all the things that happen and all those triggers and all those actions and all those layers that you cross through, there's actually a lot of things going on. So what is my risk? What do I actually really care about? So I started with the risk of someone can't log in. But if I look at it, number one, they've got to get to the login page. Well, that's a risk, isn't it? What if they can't get to the login page? Maybe I should write a small automated test to make sure that there's a link in the navigation and it takes you to the right place. Is the login page built correctly? That's another interesting risk. Is it rendered correctly? Are the fields there? Are the forms there? Is it nice font? Is it the right size? Is it clear? Is there placeholders? Tons of stuff going on there that I might be interested in testing. Can the user interact with it? Are the fields enabled? Are they disabled? Is there issues with password prompts and things like 1Password getting in the way? That's interesting risks. When I fill the fields in and I click send, or I click log in, are my details being passed to the API? Is it the right details? Are they hard-coded? Have they been encrypted the right way? Maybe there's some risk there. When it gets to the back end, are they being parsed correctly? Perhaps I might be sending duplicate usernames or duplicate passwords. Who knows? But I'm then interested in the system parsing it correctly. When I send them to the database to say, is this, password correct? Obviously there's lots of awesome mechanics going on when you do that, but that part of the system. And then we've got the going back up the stack. So now the database is going, yeah, they're fantastic, and it creates a token or a key or an authentication hash or whatever it is in the way your system works. That ends up coming back up via the API to the interface. The interface goes, oh, you've told me that's good. No worries, I know what to do now. I'm going to render the next thing for you, and I'm going to redirect you to the room page. You see, that's a very simple scenario, but there's a lot going on. So yes, I could do a single UI test that tests that I can log in. But that's now touching a lot of moving parts. There's a lot of dependencies that could cause that to fail. So is that going to be a targeted automated check? No, it's simply not. It's covering a lot. Is it necessarily a really bad automated check? No. In some teams, in some contexts, that might be a solid approach. But now in modern teams with modern architectures and people who really care about quality and having developers engaged with you, we should be looking to automate 10, 12 different scenarios there and actually have smaller, targeted, contained automated checks on the right layer targeting the right risk. So that's what T is, that's targeted. So to remind you about targeted, I want you to think about risk. I want you to think about seams and layers, and I want you to think about the testability of your team. So those are the things to take away and ask yourselves around your existing automated checks and new ones. Are they targeted? Next up, we have reliable. To maximize their value, so when we talk about value, it's an interesting word and it means a lot of things to different people. But to you as a team, when we talk about automated checks, and the reason why we tend to have automated checks is because we're looking for rapid feedback, we're looking for knowledge, we're looking for change detection. We're looking to be told that when we built this, you asked me to tell you if it ever stopped looking like this. It doesn't look like this anymore. Oh, that piece of information, you go, all right, yeah, that's really interesting, thanks, I'm going to go look at that. Or you go, yeah, whatever, right? That's what we mean by value here. Is the information you are getting back from your automated checks useful and helping you and your team make decisions? So to maximize their value, checks need to reduce flakiness. So we've already spoken about this, right? And a few things that I want to bring up here. Like number one, you can never get rid of flakiness, right? So if anyone's told you you can get rid of flakiness, you can't. It's always going to be there. There was a fantastic study by Facebook that I'm sure someone who's watching can go and Google and put in the chat, where they basically said they've been trying to get rid of flakiness forever and they've just given up because you can't. It's always going to be there. Systems are complex. The code, the tools that we're using are complex. Our own code is complex. So there's always going to be issues. So you can't get rid of it, but we want to reduce it. And that means by taking a proactive approach. So if we start to spot it, address it. Don't ignore it. Don't gloss over it. Don't do what I do and rerun the build, right? Let's try and fix it. Let's try and fix it. And if we can't fix it, let's ask ourselves, is this check valuable? Because if it's not, and because of the flakiness, get rid of it. Move on. Get rid of it. Write a different one. Maybe on a lower layer, lower seam, but get rid of it. And that's because we need them to be deterministic. A large part of automation, as I said, is change detection. But when it comes to automated tests anyway, I observed the system myself as a human being using my fantastic human brain, and I saw the system do this. I wrote some fantastic automation code that checked if the system still does this. And I want you to just run exactly that and tell me if they're the same anymore. That's what we mean by deterministic. We don't want it to start going off and doing different things in different times. You've got other fantastic automation tools to help us with things like that. When it comes to an automated check, that's what we want it to do. So that's what we mean by deterministic. So yeah, we want you to think deterministic. Is it reliable? Is it always doing the same behavior? Yes, fingers crossed it is. Think about time. Is it actually executing it a sensible amount of time? Or is it actually eating up a lot of your time because it is flaky and it is doing different things? And then think about rapid feedback loops. We're going to focus on them a bit more later. But that's what we want from our automated checks. We want rapid feedback loops. The faster we're getting information, the better. So the I is for informative. So the I is for informative. Passing and failing checks need to provide as much information as possible to aid exploration. So the important thing here is passing and failing. So when checks are passing, we want to be able to know a brief look, or from our own memory, because we're regularly looking at our checks, what did it check? So again, things like well-named, good descriptions, however it is your team works, but you've also got to think about the passing one, okay? That's often overlooked, right? We need to know if it's passing, what does it mean? What areas have been covered, what areas haven't been covered? We should hopefully be able to decipher that quite quickly. And then obviously failing. Checks are always going to fail. We want them to fail. As silly as it sounds, right, that's the whole point. If they're failing, that's great, because they're telling us they detected some change, which is why we wrote it in the first place, because there was a risk we were concerned about, and it's telling us that there's been a change. So we want them to fail, but when they fail, we want them to help us. We want them to speed up that debugging process. We want them to be able to tell us that, hey, I think it might be over here. Here's a video, here's a screenshot, here's an API JSON dump, here's some log files. We want them to be able to do that. Here's the system still in its broken state. That's fantastic. So we want them to be informative, so design them to be informative. So they provide as much information as possible to aid exploration. So a failing check is an invitation to explore, right? That's a common thing that I've said, 𝒄𝒏𝒄𝒆 says as well, because it's true, right? When checks fail, it's literally your own little mini army of robots saying, hey, I found something! Come over here and have a look. There's something you really want to see over here. It's like, yeah, I do, let's go. So when we go, though, we want to go with a few other extra pieces of information so that can help us debug quickly. And even when they pass, we still have to make decisions as a team. I often joke a lot about this, but it's really true. When that build goes green, right, and you look over and you go, oh, green, nice. That little nod, that little nice, is so valuable because you're putting it into context. Your little army of robots can't put it into context. It's no idea what's going on, but you can. So you might look over and be like, green. But like, we've had an absolute nightmare for days. Like, no way can that go green. And you might be a bit like, I'm going to have a little look at that. I'm going to have a little look, see what's been covered there. Perhaps there's few scenarios that haven't been covered. Or, we always, there might be the odd, piece of code that's incredibly complex. Might be a certain, a feature that sort of has issues in the past, and you just get a little bit, no, I'm not entirely sure about that. That's exploration. That's still you putting it into context, but using the information from your automated checks. So when we think about informative, we're thinking debugging, because our checks are going to fail, and when they do, we want to learn quickly. We need to think about decision making, because that's what we're doing as a team. We're using our little robot army to help us make decisions about whether we should ship this or whether we need to do more exploration. And then, of course, think exploration, right? Your checks are basically screaming at you to come and learn something new about the system. They've been able to spot something that you didn't know was there, and now you can go and learn something new, which might lead to improvements around the system, different decisions being made, bugs, features, who knows. But to do that, you need to go explore. M is for maintainable. Automated checks are subject to constant change. And what I mean by this is, your team, you have a job. you have a job. So your teams are always trying to build code. They're always trying to add features. They're always trying to make improvements. So therefore, your system's under constant change. Your system probably has a massive amount of dependencies. Third parties from NPM and NuGet and all these other places, Maven, right? So does your automated code potentially, depending on what tool you're using. So there's constant change all the time. So in order to deal with that change, we need to have a high level of maintainability. And basically, maintainability, our ability to maintain, but we need to be writing our code and using these tools in a sensible way that makes it easy to maintain them. Common practices out there, don't repeat yourself, keep it simple. There's things like page objects, screenplay patterns. There's a ton of design patterns out there, but we need to be using them because your checks are going to fail. They're going to fail. Accept it. It's going to happen. And when that happens, we need to get them back up and running quickly. It's like I said, I like to use the analogy of an army of robots going off looking for me. Those robots are going to fall over from time to time, right? They're going to have a few issues. I'm going to upgrade their chipsets and they're not going to be happy. But when that happens, I need to be able to do that in a way that's efficient for my time so that I can get them back up and running quickly, get that rapid feedback and get the value from them. So maintainability is crucial. Do have a look at some of the good practices that are out there for writing good, clean code and good, clean automated checks, and get the whole team involved. Every team has developers, incredibly talented people who have a lot of knowledge about writing clean code. Get them to have a look at some of the automation too, if they're not already. Hopefully they are. So yeah, think design, think clean code, and think good practices. Okay, the last one is speed. So speedy, but execution and maintenance. So execution here, I mean the actual execution of your automated checks when your CI kicks it off or you click play, that time that they take. And maintenance, we've just been discussing, fixing them when they fall over, investigating failed tests, improving the system, upgrading the system, needs to be as fast as the testability. So we want it to be as fast as possible, which is dictated by the testability of our team. We can only do what our team's able to do. That allows us to achieve rapid feedback loops. So I've been mentioning rapid feedback loops a lot, but if you just think about it as your checks are checking things that matter to you, how quickly are you getting that information back so you can make decisions? That's what we mean by rapid feedback loops, and that is a large part of why we automate in the first place. So we often only talk about the speed. We often only talk about the execution speed. When we say, oh, we need our tests to be quicker, right? We need our automation tests, automated checks to be quicker. Now, when we discuss that, we're often thinking, oh, right, yeah, the execution. Make data generation quicker. I'll parallelize it. I'll buy 5 more cloud instances. I'll buy LambdaTest and we'll run it all on there and it will be like 5 times as quick, right? Sure, but that's only a small part of the wider picture. We also have the reporting phase. How long is it taking for you to get this information? Is it being processed in a way? Is it coming back to you in a digestible manner that your team might want? Some people might want a report. Some people might want it to plug into a test case management tool. Some people might want a ping in Slack. Depends what you want, but how quickly are you getting information of failures with informative information in there, or how quickly are you being given information about passes? So you've got to think about the reporting side. There's also the maintenance side. How long is it taking you to maintain your checks? We've already discussed it's going to happen. They're going to break. So how quickly can you maintain them? How quickly can you get them back up and running? And there's lots of practices that can be put in place there to make that easier. If you've got an incredibly complex, horrible many layers of code, that maintenance time is going to be high. It's going to be really high. And then finally, we have the creation time, which again is often overlooked. How long is it taking you to create your automated checks? To create an automated check, you've got to get some information, right? You've got to exercise the system. You've got to trigger it. You've got to see behaviors in real time and actually decide if they're acceptable or not. You've got to design your oracles, your assertions. You've got to do, quote, manual testing, but like exploratory testing. You have to get some information in order to be able to then codify it into an automated check. So that time can also be quite lengthy. You might not know what's good or bad. You might not know what your assertions you should be, what your oracle should be. You might not be told from the product owner or other stakeholders what they care about yet. The quicker you can get all that kind of information, the quicker you can build your automated check. So there's not just execution, which is often the thing that I hear spoken about. When we talk and I talk about speedy, I mean all these 4 different factors of it. So yeah, with regards to speedy, think the reporting time, how quickly do we get back, think execution time, think how long and analyze how long it's taking you to fix and maintain your automated checks. And I've missed one off, but think about how long it's taking you to create your automated tests. So that just leads me to kind of prompt you going forward. In my opinion, the main reason we automate tests and automate checks is to help us achieve rapid feedback loops. I need, in my team, to know that everything I believe the system still does is still true. And that's what I get for my automated tests. When I run them, I said, I think it's currently 17 minutes on our Ministry of Testing website. When I get that green build, because I'm regularly looking after my checks and grooming them, I'm aware of what they do, I get an immediate sense, I get feedback that I can put into context and then make a decision about, yeah, let's ship it. Let's wrap this feature up. Let me mark that job as done. I can make that decision because I've got that feedback. If I'm waiting a long time for that feedback, I'm taking longer to ship my product, I'm taking longer to make decisions, and that's slowing us down as a team. So we want rapid feedback loops all the time, which is far more than just execution. It's about the creation, deciding what to automate, maintaining it, investigating broken builds, investigating broken tests, unreliable tests, flaky tests. It's the whole thing. So in order to if I look after all them and I apply the trims, mnemonic, I'll hopefully achieve rapid feedback loops. So I'm going to leave you with 2 questions. Are your feedback loops rapid, or do they need a trim? All right, thank you for listening to me. My name is Richard Bradshaw. If you want to follow me on Twitter, you can at @friendlytester. I work at the Ministry of Testing, who you can follow at Ministry of Test. On Twitter, I'm also on LinkedIn. I'd love to connect with you on there. And if any of you are ever interested in training in the automation space, I run a course with my colleague Mark called Automation and Testing. So have a Google, have a look on Twitter website. You'll find all information about me. I really appreciate you taking the time to listen to my keynote, and I look forward to answering your questions. Thank you very much.
Hi, Richard. Yep.
Hello. How you doing?
Yeah, quite an insightful session, Richard. Thank you so much. Personally learned a lot. I hope it has been, very fruitful for people to hear about the session as well. I can literally see you have been very active on the chat, and people enjoy chatting, asking questions there. But there are quite a few questions on the Q&A chat, which I'm gonna pop in. The very first question.
Yeah, sure.
If you could see, what will be the future of manual testers in upcoming years, from Vikrant?
I lost track how many times I've been asked this question. I think it's a real difficult question to answer without having some sort of specifics, like what is a manual tester to the person that asked the question. So if let's assume that that person is someone who is spending their day writing test cases and manually executing test cases, then I think the future of them is probably quite bleak, because they're not. If they're just writing test cases, running test cases, and marking them as pass or failed, they're losing a lot of what knowledge they're actually gaining. So there's a great talk by Alan Richardson, and you have this position where we thought all testers did, or manual testers, was to run the test cases and mark them as pass and fail, literally follow the steps. But it's not true. What actually happens is, and I assume you lot can still hear me, what actually happens is we follow the test cases, but we're also doing more. So if a test case says, check that there's a logging field, of course we check there's a logging field, we're not silly, right? But we also look to make sure the font size is correct, it's the right color, there isn't a giant pink elephant on the top of the screen. We do a lot more assertions than what's in the test case, but we don't tell anyone about it, or we never used to. We just keep it to ourselves, right, and just mark the test as passed. If you're doing that, you are underselling yourself and you are making yourself replaceable. Because to your superiors and managers and the rest of the team, they just believe you're running a test case. And if that's what they believe you're doing, then they will automate that. So I think moving away from that, we need to get more skilled testers utilizing automation, whether that's written by them or whether it's written by the team, it doesn't matter. But having more skilled automation in place that's given us this rapid feedback, that's then putting us in a very quick position to go, do we need to know any more? And if we do need to know more, who has the skill set to help us find more? And that skill set lives in many, many roles, but really lives inside testers or quality engineers or anyone on that focus. Now, that said as well, we're also going to see a shift where I feel we move away from the system itself as such. So we also need to get testers with our mindsets about being able to ask good questions, being critical thinkers, and push that into the world where we start to ask questions about why are we building this in the first place? So, a lot commonly it's called in shifting left. I'm not really a big fan of the term shift left, but getting us involved earlier so we can ask questions, we can critique before we even waste our time writing things that don't matter, but also being able to ask the questions early of how are we going to test this? As a team, how are we going to test this? If you ask that question early on, you will get a much better system, a high level of testability, and it will be easier to do the testing. Because if it's the developers doing the testing, they're going to make it easy to test, right? They're not going to give themselves a hard time. They're going to design the system in a way which makes it easier for them to test. So therefore, ask that question early, use your skill sets, and be involved a lot earlier. So I think the future is really positive for people who focus on testing and quality work. But yeah, traditional concepts of writing and running test cases, I think that will die out because automation is much better at it. But then we will start doing different types of testing, exploratory-based testing, accessibility, performance, just generally trying to gather information as quickly as possible to allow the whole team to make decisions. So I see a lot of that shift towards quality rather than actually just sitting down and testing the system extensively. So a very long-winded answer. I'm kind of waiting for Manor to come back.
Yeah, right here. I don't want to disturb your flow. I think completely resonates what you said, Richard. Thanks so much for answering that politely. The next question, I'm kind of tempted to answer, but I'll keep my mouth shut and I'll let Richard talk about
We'll
it.
answer it today.
What is the future of Selenium? Will Playwright rephrase it?
You know what? There's going to be new tools every week. There is new tools every week. Some gain more traction than others, but there's a lot of tools coming out there. There's a lot of commercial tools doing incredible things, right? There's constant change in this space, and I think we should be quite happy about this because it shows that people are investing in testing. So new tools all the time, new investment. It's a good place to be. Will Playwright replace Selenium? I don't think so because they serve different purposes. If you look at the internals of these tools, one is like Selenium has always had the underlying objective of trying to be as close to the user as possible, which means triggering it via behaviors within the browser. Playwright and Cypress, they don't care about that. They've built their own little engines that mostly rely on JavaScript to trigger the page. So That's not a bad thing, but if you're trying to test as a user, you should use a tool that acts as a user. If you're trying to just exercise the web page, then use a tool that exercises the web page. They're very different risks, and I mentioned risk a lot in my talk. Once you know what the risk is, and if you say the words to yourself as a user, you need to put yourself as close to a user. You only had a go at Playwright. I try and have a go at every tool that comes out, even just a 5-minute hello world kind of thing. And it's great, they've built a lot of stuff into it, but because it's not trying to be a user, it never set out to be, it's trying to trigger the website. And if I need to do that, I'm happy to use Playwright. If I want to be a user, I'm going to try and use something like Selenium. Hopefully that helps.
Great to hear, Richard. That was a very neutral answer. I think if I would have answered it, people would have thought it's bias because of my
You got a
association
bit
with
more bias
Selenium.
than me.
Yeah, but I mean, completely resonate with that because that's the kind of an answer that I always say, because there's a difference between using tools that mimics, in process and out of, process context with browsers, because there's a very difference between, WebDriver W3C protocol versus DevTools protocol, which is completely meant for different purposes. So you perfectly summarized it. So thank you so much. Let's move on to the next one from Tim. I think this is something that came in one of the very few questions when we were talking about, cut shorting some of the tests. So Tim asks, what's the best practice for where to house remove tests to reference them without having to dig through source control?
I'm guessing I'm struggling with that question a little bit, Tim, as in, why would I want to continue to reference them? So it feels a bit more to me like you're trying to be in a position where you're actually doing something which is really important, which is trying to say, I have tested A, B, and C, but I have not tested D, E, and F. And if that's the case, then I feel that's a much better done as a conversation with the team. That could just be a simple message on Slack. And someone might read that and go, oh, I don't think that's a good idea. D, E, and F are really important. Can we do something about that? So I feel like for me, I just delete them. I'm not a fan of ignoring. I don't see the point. Like, you're so proud of what you built that you can't delete it. You just got to ignore it. You're doing the same thing. You're just fooling yourself. Like, you might as well delete it. And if it comes back, and the risk might come back, just write a new one. But what's going to happen is you're going to write it with all the new knowledge. You're going to write it with how you know and view the system now, which might be a lot better than it was when you wrote that original check that you're just going to ignore. So that's the key difference there, is you're going to have a lot of new learnings that put them into play. So that's what I would focus on. And then, yeah, a lot of testers, and I mentioned it with the manual testing, a lot of people don't talk about what they didn't test. We always talk about what we did test. So that's a very important thing to consider. I didn't test A, B, and C because I didn't have enough time. I didn't have the testability. I didn't have the tools. I didn't have access to the developers. My environment was broken. Whatever it may be, that's as equal as important as I did test A, B, and C, and it's all pretty good.
Cool. I think Tim acknowledges your points, saying true, good points. So thanks, Richard. You got a live feedback. All right. Up next on the most upvoted question, how important is test orchestration when you do automation testing? And what are some of the great tools you're using for test orchestration from Manish from DigitalOcean?
So I'm guessing by orchestration, they're probably referring to kind of the order that we run tests in, and how we manage that execution of tests would be my guess.
Yep.
To be honest, it's not a phrase that I commonly use. But if that is what it is aimed at, someone tell me in the chat. The way I prioritize the execution of our tests, we overuse the term smoke test, but we start with a very simple smoke test. Is the system alive? If the system isn't alive, it's pointless me even trying to run the test. And just as a very quick funny side note, someone once changed the admin password on all our tests, and it took 19 hours to fail. Not at Ministry of Testing, this was at a job a long time ago. But we didn't have enough pre-checks in place to make sure things like that were good. But yeah, in terms of orchestration, you want to be ideally running in high to low risk. That's what I would ideally do. Or potentially a lot of people focus on quick execution to slow execution. So for example,
You probably want to start with your smoke tests, make sure the system's up. Then you're probably going to run your unit tests, because they should be quick. Most unit tests are a lot quicker. Then you probably want to fly through a single browser first, just to get that through. And then if you have, in your APIs and your browser tests, and then I would then do additional testing after all those steps. In terms of what tools, we just have a bash script. We just have a bash script in CodeShip, though we just basically say run this, then run this, then run this, then run that. I don't have any other experience in any tools. There's lots of you in the chat. If you have other tools to recommend to the person who asked the question, then please suggest them. But we just have a bash script, and that's because bash scripts are universal. So if we move build tools, we can just take our bash script with us instead of having to re-implement everything again.
Thank you. All right, next up is not on the list of highest upvoted, but I seem this is kind of interesting, from Kripa Shankar. So the question is how we should come to a conclusion. We have to start trimming out the tests from automation suite. Trimming out in the development stage may cause a loss of test coverage and impact the results. Your thoughts, Richard?
To be honest, I would say it's got to be an ongoing thing. This should be an activity that you're doing continuously every week. As you're adding new tests in an area, have a look at what's already there. As a test fails and you're fixing it, have a look at some of the other tests just as you happen to be there. It's not like I've recommended it as like a phase now because I don't see a lot of teams doing it. So I would definitely encourage anyone who isn't doing it now to schedule some time as soon as you go back to work to try and do this. But ideally, it's an ongoing thing. Some of the triggers, again, tons of flakiness, low confidence in your results, low confidence in your build, running your build just feeling like it's going to fail, complaints by other members of the team that the builds aren't good enough, the failing test always being the point of failure or the blame for why builds are not building. Then you've got kind of your own pain points. So are you missing things? So are things going live and there's bugs in production or issues in production that you believed were covered? The odd shot like, what? There's no way that's broken in production. I've got loads of tests in that. And then you look and you're like, oh, wow, they're really bad. So those are kind of the triggers, but ideally an ongoing initiative. Do it in pairs, do it in groups, do it in ensembles. It's the same with any code. Code gets regularly peer reviewed. A lot of the time when devs are building new features, I spend a lot of my time being a developer now, right? I'm looking at the existing code. I'm looking at other screens to see, how did I build it on that screen? Oh, I built it that way. Oh, how did I test that? Oh, wow, I didn't even realize I knew that skill, right? You've got to be continuously going through those processes.
Thanks, Richard. Next up, Richard will take last two questions and then
Sure.
we could conclude. And next up is from Kamal. How do we quantify the value of a test?
I think I mentioned it in the talk, but is it helping you make a decision? That's the easiest way
simple.
To do it.
Yeah.
Is the result from that helping you make a decision? If that result is just making you go, is that useful to you? Probably not. If you're looking at it going, that's a really useful piece of information to me, that's going to help me make a decision that we ship our code, we move to the next stage, however your team works, then I think that's kind of what you're looking for here.
Cool. Next question, slightly related, but how often should automated tests be audited?
Like I said before, like continuously. One of the things I mentioned before is we're using them to make decisions, right? And I joked about the nod of looking at a green build and being able to put that into context. But it's impossible for you to know what every test is, right? I think there's like nearly 3,000 at MOT, and we're not a big product, right? Other teams have tens of thousands of them. It's impossible to always know what they all do. But we regularly have to be aware of it, ideally aware of what some of them are doing, or at least, I don't want to say the majority because that's a lot, right? But if we're trusting green, we need to have a concept of what green is. So we call it the illusion of green. I've got a blog post somewhere called The Illusion of Green. It's where we believe we have all these tests in place, but what if we don't? What if it's so long ago that we didn't write it? So you have to keep auditing, do it regularly, and as I said, it's very easy to make it part of your day-to-day work. Do it when writing new ones, do it when fixing broken ones. And also, most of you are doing maintenance anyway, updating your gems, updating your libraries, upgrading to the latest version of whatever tool it is you're using. Just try and weave it into your day-to-day practice, just to go and have a look at a few existing checks. And a really good a really good member of the team to do it is anyone who joins new. Anyone who joins new, whether experienced or absolute newbie, get them to read some of your tests. And if they look at it and go, why? Listen to it. Don't question it immediately. Don't be like, how dare you? Listen to it and go sit with them and go, what do you mean? And then dive through that test and see if it's worth it or not. Another good metric, is when was the last time it failed? Like, when was the last time that test failed? Because that's probably showing that it's a part of the system that's really stable and maybe you don't need any tests anymore. Or is it a part of the system that's constant changing and failing a lot? And as I said in the talk, we want them to fail. It's good that they fail.
Fantastic. Slightly related again, Richard from Ruth. Ruth asks, is there a magic number as an acceptable build time?
The CI/CD will talk about 15 minutes. That's the number that I tend to try to stick to as much as I can. But again, it's so contextual. If your system is an absolute beast, it's going to vary. So I would say 𝒂𝒂💂. If you listen to the wider industry and the gurus, they talk about 15 to 30 minutes. But what I would suggest actually is a better number is to sit down with your team, discuss your context, and as a team, pick a number and stick to it. Don't let it slide. If you sit down as a team and you say 2 hours, it is now 2 hours. Make sure the team accept it. If the build goes to 2 hours and 2 minutes, that is now the number one thing to fix. Not the next feature, not the next thing. It's to get that build down to whatever it was, 2 hours. Because you've said as a team that that's what we need, and you need that rapid feedback. So therefore, ideally 15, 30-ish minutes, whatever, but more better, contextual with the team, and please stick to it. Don't let it slide. Because once it slides once or twice, it's gone. You'll never get it back. Because it will become too big a job to get it back. It will now become 6, 7, 8, 9, 10 minutes. And you'll never get the prioritized time to do that. So don't let it slide.
Thank you, Richard, for your wonderful session. I hope to all of you listening, that should have been quite an insightful session from Richard. TestMu can't get any better than having Richard's insightful keynote session on it's time for a trim. I hope you go look back at your tests and start, trimming it based on the mnemonic. Yes, like Richard's beard, aka the friendly tester, aka the friendly tester. Thank you so much again, folks. I think Richard will be available on the launch section if you want to hang around for 5-10 minutes. We're gonna end this session now, and thank you so much for joining for this keynote. And we have a day long. The day has just started for TestMu, and there's quite an insightful other sessions coming up for you. So go look at the agenda and join other sessions. And thank you, Richard, again. We know you are not feeling well, and thank you so much for taking efforts and making it time for us. It shows your true commitment for the community and for all of us at LambdaTest. Thank you so much.
Thank you so much. Cheers, everyone. Enjoy the rest of TestMu. Bye for now.
Thank you. Bye.